astronaut David Scott dropped a feather and a hammer on the moon, confirming Galileo's belief that in a vacuum, objects of differing weights accelerate to the ground equally as fast. In the 17th century, Isaac Newton had the idea that the motion of an apple falling down is the same physics as the moon orbiting around the Earth. Standard gravity, or G, is 9.80665 meters per second, or 32.17405 feet per second. As a fraction, it is 32 feet, 2 and 3/32 inches. With this chart of theoretical freefall speeds and distances in a vacuum, we see the speed gets faster by g every second. Note, the first second is calculated to be 16.1, or 1/2 g. Now let's look when Jeff Bezos became an astronaut. His New Shepard space capsule went 351,210 feet, or almost 67 miles above the ground. With no air resistance, the capsule fell 9,731 feet after 25 seconds. We'll go to the Keeson online calculator. From Education, click Science. We'll choose Free Fall Distance and Velocity. Input 25 seconds. We see the object would normally fall 10,054 feet if the capsule was dropped near the surface of the Earth. When we adjust the gravity to 9.49123, it now matches 9,731 feet. That means objects fall at only 31 feet per second at that altitude. A geostationary satellite orbits with radius r to the center of the Earth, or 42,164 kilometers. The velocity, or v, should be 3.074566 kilometers per second. We're going to solve for velocity using this equation, with big G being the gravitational constant and m for the mass of the Earth. This is the gravitational constant. This is the mass of the Earth. This is the radius in kilometers. Gravitational constant and mass without the scientific notation. Radius converted to meters. After multiplication, kilograms cancels with the kilograms to the -1. Meters cubed divided by meters makes meters squared. We just divide these numbers, then find the square root. The square root of meters squared is meters. This becomes per second. Multiplying by 1,000, we get kilometers. Now let's look at the moon. The moon orbits with a velocity of 1.01748 kilometers per second. From the center of the moon to the center of the Earth is 385,000 kilometers. Big G times mass is the same as before, 398 trillion. This time we divide by 385 million and get the square root. It is 1,017 meters per second, or 1.01748 kilometers per second. The other way to calculate velocity is to use the Pythagoras theorem. B is the radius, A is the velocity, and C minus B is the distance fallen in 1 second. Here are the numbers for a geostationary satellite and the moon. I find it most interesting that an object could be falling straight down and be weightless, and an object could be falling around at the same time.